Good day to you, everybody, and welcome to our final video lesson here for Unit 2. All right, in this video lesson, we're going to tie together some of the major concepts that we've been looking at so far throughout Unit 2. We'll look at a little bit about motion here, a little bit about velocity, and a little bit about speed. What are we going to examine exactly, tying all three of those together? We're going to look at acceleration. Topics that we're going to cover in this video will be a general description for acceleration and how it relates to velocity and time, the types of acceleration and how we calculate acceleration, and finally we're going to check out motion in multiple directions, or motion in two dimensions. All right? So acceleration, what the heck is it? Well, let's check out a video example with the assistance of two wonderful volunteers, Mr. Abe Elder and Mr. Nick Holthouse. All right, I'm picking Nick. Who are you picking? Abe. They're off. Oh, Nick's in the lead. Oh, Nick's going to win. Oh, Nick, that's a quick touch. Oh, it's going to be first around. Look at Abe. Oh, they're giggling. They're having such a good time. And Nick's the victor. Oh, man. But Abe, not one to not show off. Thumbs up from each. Good. Well, what was going on there? From the video, I saw a few things. I saw a change of position, i.e. motion. I saw a distance covered over a certain amount of time, i.e. speed. I saw speed in a certain direction, i.e. velocity. But I also saw adjustments in speed and velocity as the two ran through the course laid out in the gym. Anytime there is a change in velocity, an object is said to be accelerating. Acceleration is commonly seen as speeding up, but it can also be slowing down. With velocity being speed and direction related to one another, that means acceleration can change with a change in speed or a change in direction or a change in both. Let's check out the video again and kind of outline some of those one more time. Okay. Let's take a look at this video one more time in this race between Abe and Nick, and let's note when we are seeing changes in acceleration. So they're both going to start off.
Marks, set, go.
Right away, we are going in a set direction, but our speed is changing. So initially from the starting point, these two are accelerating. Now their speed is also going to change when they go ahead and they come upon this chair up here and they want to turn left. So we're going to have another change in acceleration, but it's going to be opposite. It's going to be the opposite direction that they're originally going. Change in acceleration. Now, again, another change in acceleration. So we saw it from the starting line. We saw it here at the front of the chair. We saw it here as they left the chair. Now we're seeing them in a constant velocity. They're possibly not accelerating. And now they start to change their acceleration again as they come upon this other chair. And it will change again as they leave the chair. Again, a change in acceleration as they touch the line. So they slowed down to make sure they touched it. So they changed their velocity. And they went ahead and changed their direction. Just like they did when they went around the chair. So acceleration, changing. Now here's an interesting one. As we're seeing acceleration in a circular motion. Okay, so their speed could be constant here, but their direction is constantly changing as they are going around in a circle around the chair. We'll talk about that here in topic 3.
You watching the kids, are you?
Yep, doing a little video here.
Thumbs up.
And that is the video and a little evidence of changes in acceleration as they're running through the obstacle course. Hopefully that helps clears it up a little bit for you guys. So, as we saw in the video, acceleration can be speeding up, it can be slowing down, or changing direction. Simple. 3 types of acceleration right there. So it should be pretty simple to remember and understand those. Speeding up, slowing down, changing direction. Now, how do we calculate and figure out a numerical value for acceleration? Well, we do that by using this formula. A equals final velocity minus initial velocity, all divided by time. A equals VF minus VI over time. Sometimes we can end up with an acceleration reading that is negative, and that's okay, all right? Don't freak out about that. All that's telling us is that acceleration is happening in the opposite direction of the original way you were going. Final topic for this video, motion in multiple directions, or motion in two dimensions. To this point, we've really just focused on objects moving in a straight line, all right? But motion is not restricted to just straight lines. Like displacement measurements, we cannot add or subtract motion that is not in the same direction. We refer to each separately. The same goes for acceleration, because when an object is changing acceleration, it's not changing in the same or opposite direction of its velocity. Not always, okay? We can only combine distances for displacement, velocities, and acceleration when their movements are indeed in the same or opposite direction, okay? So we can add accelerations or subtract accelerations that are going left and right, but we cannot one where it goes left and forward or right and backward. Same thing with velocities, and same thing with distance measurements when we're talking displacement, okay? Due to motion being able to occur in multiple directions, we've developed a couple of ways to describe the change in acceleration across two dimensions. Those two ways are circular motion and projectile motion, okay? Circular motion can be best described with the classic example of a carousel. The horse is moving at a constant speed on a circular path, but it is accelerating at all times because it's constantly changing direction. The velocity of the horse is actually pointed directly towards the center of the carousel, or in other words, perpendicular to the horse's acceleration or the horse's path. We call this acceleration toward the center of a curved or circular path centripetal acceleration. Projectile motion refers to both the horizontal movement of an object and the vertical movement of an object. When you throw or shoot an object, you're giving it horizontal velocity, a lot like a baseball being pitched towards home plate. Naturally, gravity does work on the object and gives it vertical velocity as well. So, we've now got movement in two dimensions. Horizontal, as you throw it on a horizontal plane towards home plate, and vertical, as gravity does work on it and points it and pushes it downward. Projectile motion, therefore, typically describes motion of a curved path. An object takes a curved path due to both the horizontal and vertical movement of it. We'll be doing a lab here in Lesson 3 that will further deepen your understanding of motion in two dimensions. All right, well, that does it for Lesson 3 here. We can wipe our hands clean of Unit 2 material. Make sure you've taken notes and that you've filled out a good summary on that WSQ and that you've recorded some quality questions that you would either ask me or ask others. Take your time with these WSQs, okay? Put some work in here with these videos and with the WSQs. It will only help your understanding and quality completion of assignments or labs inside the classroom. With that, I say adios, have a good one, and I'll see you later.